Hello, it's dumplet here. Here's an item on evaluation. Evaluate the long expression below. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, you guys might try it by starting to evaluate this one first and then this one. So, starting from the innermost parenthesis and work your way outwards. That's alright, but the first time when I saw this item, I tried to expand a little bit, but not really fully expand, but just to see how each term will turn out in this expression. So, well, the first term I'll get is just 2014 times 1 over 3 factorial. So that's going to be 2014 divided by 3 factorial. And I realized that the 2014 would distribute to this 2013, which would make 2014 times 2013. And then this multiplies with this 1 over 4 factorial. So essentially I'm subtracting 2014 times 2013 divided by 4 factorial. And then I realized what's going to be the next term. So I'm going to have 2014 multiplied to this 2013, and it's going to distribute to this 2012. So I'll have 2014 times 2013 times 2012, and I'll have to multiply this with the 1 over 5 factorial. So the next term would be, well, I have two negatives here, two negative signs. I know it's going to be positive. So the next term that I'll have in this expansion is plus the 2014 times 2014 times 2013 times 2012 divided by the 5 factorial. Now I know like the pattern is going to continue, and well, the last term is just going to be 2014 times 2013 times 2012, so on and so forth until 3 times 2 times this 1 over 2016 factorial. Now in fact I have a pattern here, and this is the pattern that I saw, and technically we have the p here means it's a permutation. So like 2014 P1, that's just taking 2014. Now 2014 P2 is like 2014 times 2013. So that's just 2014 taken 2. So you can read the P here as taken. But it's the permutation notation. And this is the pattern that I got. So let's try to see what we can do with this, because, well, there is a pattern. So there might be a nice way to express this expression. So we can use the following, NPR, or n taken r, it's equal to n factorial divided by n minus r factorial. It's just basic fundamental counting principle formula. And the 2014 P1, I can write it as 2014 factorial divided by 2013 factorial. Now if I combine it with the 3 factorial in the denominator, I'll get this term. And you can try to see that 2014 P2, that's going to become 2014 factorial over 2012 factorial, and I have the 4 factorial in the denominator. Same for this, 2014 P3 over here, it's going to be equal to 2014 factorial over 2011, and then the pattern will continue. Now I've noticed something very nice, and it's that, oops, I forgot a factorial symbol here, and what I noticed is that the denominator, like, it's of the form k times 2016 minus k factorial. So like 3 and 2013, they add up to 2016. Same for 4 and 2012, 5 and 2011, and so on. So I tried to manipulate this expression a little bit, and you will see the motivation behind it clearly. And I decided to make all of the numerators equal to 2016 factorial. So as you can see here, I made it 2016 factorial for each of the expression, and just to make this expression equal to this expression, I have to multiply this 1 over 2015 times 2016, so I don't change the value. Now why did I make it like this? Because this expression is of the form n choose r, so the binomial coefficient, in fact this first expression I can write it as 2016 choose 3. Because if you're going to recall what n choose r is, like say n choose r, that's equal to n factorial over n minus r factorial. It's the same as the permutation formula, except there's an additional r factorial here. So you can compare n choose r with all of these, and it's going to look like, it's going to look the same, in fact. So like the first term over here is 2016 choose 3. The second term here is 2016 choose 4. So I'm subtracting 2016, choose 4. And then I'm just going to write the entire thing down. Even if I continue this, I'm going to get the following. So I have this. Now, how do we evaluate this is a key takeaway in this item, and that is to use the concept of a generating function. Now, I guess the very obvious place where we would use a lot of these binomial coefficients is via the binomial expansion. And in fact, if I want to consider the following, so consider the following, negative x minus 1 raised to 2016. If I'm going to expand that via the binomial theorem, I'll get the following. So it's technically negative of x raised to 2016, the first term, and then, well, technically 2016 choose 0 times x raised to 2016, but 2016 choose 0 is just 1 anyway, so I just made it into x raised to 2016, and you see that this is going to be the expansion of at least this expression, negative of x minus 1 raised to 2016. Now, what's nice about this is that part of what we need, or what we want, is in this function. Now, well, obviously, don't mind the x for now, but there is the 2016 choose 3 minus 2016 choose 4, and so on. And what can we do with this? It's very nice because, well, why not just make this expression, since we know like this is the expansion for negative of x minus 1 raised to 2016. We know it's an identity, which means I can substitute any value for x and it should be true. So why not evaluate this expression at x equals 1? Now, why do I want it to make it x equals 1? That's because this becomes negative 1, and all of these become 1, right? So the resulting expression actually is negative 1 plus 2016 choose 1 minus 2016 choose 2 plus so on and so forth. And this equals 0. Now, why 0? Because it equals negative x minus 1 raised to 2016. But if you substitute x equals 1, you're going to get 0 anyways. Now, what's nice about this is that the underlined portion here, w, if we go back, it's exactly the value that we want. I let it to be w for want. So all we have to do is just find the value of this want. And in fact, we can just move these three terms to the other side. So w is just going to be equal to 2016 choose 2. Well, 2016 choose 1. That's 2016. So I'll just make negative 1 plus 2016 together just be 2015. So w is just 2016 choose 2 minus 2015. And we can do a little bit better because 2016 choose 2, that's just equal to the following. It's just equal to 2016 times 2015 divided by 2. So this is just the equivalent form of w. Now, since this equals w, as we've seen in the previous slide over here, all I have to do is just copy this value for w, and then I'm going to insert to this part. So since this part is w, I'm just multiplying by w now. So w becomes this expression over here, and all I have to do is just evaluate this. So let's distribute this factor of 1 over 2015 times 2016. So this one becomes 1/2 because the 2015 2016 cancels. So the first term is just 1/2, so you just write 1/2, and then we're subtracting it by, well, the 2015s cancel in the second expression, so it's just going to become 1 over 2016. So that's 1/2 minus 1 over 2016. Let's make it into one fraction. It's just 1008 minus 1 over 2016. If we evaluate this, we're going to get our final answer of 1007 over 2016. And this is indeed our answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!